Um, the first two lectures, we covered the chapter 11 of your textbook. Today, I try to wrap up chapter 11 and go into chapter 12, which is the topic of overloading. So, oh, wait a minute. Think show up? Very strange. Okay. All right. Yeah, I always amazed about this type of problem. Means that the PowerPoint slide, this kind of thing, for me is at least 20, 25 years. We still cannot fix it. All right. So I try to wrap up what we have talked about so far. So we have a system. The system represents some interests of our society or our corporate trying to develop some kind of service. And what we want to do is the object-oriented modeling is trying to capture the important information in the system, which I call it the target environment, and represent with a class. I mean, for example, just an example. For example, we talk about class GPS. We talk about class person. We haven't talked about class person, but I will talk about that today. So we try to model that as a class, which class is a template or specification about how we can create the real object. And to represent this, we have to develop code. So you have to see that we develop code such as GPS.h, which represent the structure about that class, which essentially is a specification for us to do the instantiation or implementation. And then based on that class, we have three files over here, at least three files, maybe more. One is GPS.h, one is GPS.cpp. This, well, syntactically, you potentially can put GPS.h and GPS.cpp together in the same file. But it's really inconvenient. Later, when you see a large scale programming, you want to use multiple class, you want to kind of doing a real world deployment, you realize that it's almost like you must separate them into the part which is just worry about the declaration of the class, which is the GPS.h versus the definition or implementation of the detail, which is GPS.cpp. You'll have to separate them. And then last time I showed you, you can have a test program, which I put a main.cpp here, but it's a program that will really instantiate. For example, here I only put one line. You use that definition, GPS_DD, to create an object called Costco, which is represent the Costco's GPS location. And this program is really just try to using those two programs to create a bunch of objects to try to realize this target environment we try to deploy. Okay, and then this is what we call the compiling. So for homework assignment number 1 in the makefile, you actually saw me as a multiple rule. I haven't talked about makefile. Let me just show hand. How many of you have used makefile before? Okay, that's great. I mean, this is for some reason this particular class, the percentage of the student already know the stuff from usually cover ecs36b. The percentage is really high, much higher than I have seen before. So that's good. Okay, so in the makefile, you have a different rule. This is sometimes we call a separate compilation. So you can see that I compile the GPS.cpp separately, then I compile main.cpp or test.cpp. So just remind you, I put the -c flag just the way you use GCC. If you use -c flag, that means you will have the program, either GCC or G++, to stop right after generating the object code. So there is a 3 thing, you might have heard about this before. In G++ or GCC compiler, one is called preprocessor, one is called compiling, one is called linking. Okay, preprocessing is handling something started with the first character pound sign. Anything statement with a pound, that was handled by preprocessing. So sometimes you want to see, well, what is this preprocessing is done to my code? You can use the G++ minus capital E, and then that will help you to stop right after preprocessing. So you will see that what kind of statement got included, which is very useful when you do object-oriented programming, because you want to know, what kind of class definition or declaration has been included that sometime will help you to determine debugging. Okay, but anyway, I'm using -c, which will stop at the compiling. And so the result of this, you're going to get this two object file. One is called gps.o, one is called main.o. And then you will just link them together. And then this 2 will be linking together. Usually there is a one rule to help you to link all the .o file with all the library that's already included in your system. And then you will generate an executable. And then when you really run that program, then essentially your code is going to generate a bunch of objects, which in some sense, you're re-representing everything in this complex system. Now you have a bunch of objects. So this is kind of the picture. Talk about the process about how to do object-oriented programming. I hope I went through a very simple example, such as the GPS location, trying to understand the distance. It's really, really simple example, but it shows the whole cycle about how from the modeling all the way to object creation represented. Okay. Okay, so that's pretty much conclude what I really want to cover. The most important part in chapter 11 of your textbook. So I'm actually going to the next one. The next topic is going to be chapter 12 called operator overloading. All right, so I'm going to first use an example from your textbook in chapter 12. And then through that, I will bring this example back to our own example, such as GPS, such as person, to see what does that mean to be operator overloading. So first I will explain the concept of operator overloading. So operator overloading is trying for you to redefine certain operator in your programming language, but with a different meaning. So in some sense, if you see an operator, I gave an example, greater than is an operator. So if I told you what's the meaning of the greater than, you will think, okay, it's just comparing how big it is, right? That's the meaning of the operator. But when you compare two things, for example, you want to compare two person. If I say person A is greater than person B, what does that mean? Anybody want to provide a guess? There's no definite answer, right? The greater than may be greater than in age, greater than in their other feature, or greater than about their psychological status in that moment, right? So sometimes the operator itself might have a different meaning. That's one perspective. And sometimes we want to use this operator to represent a lot of real world scenario. If you think about natural language processing, sometimes say somebody use some adjective and then try to use something related to a logical operation. And then that's really interesting application, also sometimes introduce confusing. So I'm going to first tell you what it is, and then we will see under what situation it's appropriate to use operator overloading. Okay, I'm going to use this example. In your textbook, it used this example called box, a class called box, box.h or cube in this example. So essentially, we want to have a object, and then we want to compare the size or the volume of the box. And so if you want to do that, I will use this statement. I said box one compare volume box two. Okay, so box, by the way, is a class, and box one and box two are objects instantiate from the class. Okay, if you look at the statement, this is, by the way, this is from exercise chapter 1102. If you see that, this is an example from the textbook. If you look at this example, let me write it down here. The scenario what we're talking about is object one dot sum of the I call a member function, and then in the parameter or argument is another object. Okay, so that's what we're doing. Object one dot member function, and then the other object. So in some sense, this object, object two, is argument being passed into one of the member function for the same class, but belong to the other object, right? That's the structure we're using. So essentially, this is trying to compare the size of two different objects belong to the same class. Okay, by the way, it's not restrict that this kind of function must be, or operator overloading, this thing must be the same class. For example, I could easily have a function have this format of object two of another class, okay, another totally irrelevant class. That's also possible in general. Okay, so this is kind of the format. If you look at box one dot compare volume box two, this might remind you about our distant function. If you remember the distant function is the object one, which is the Costco GPS, dot distance to TLC as another object. For example, that kind of format happened a lot. Okay, so this is the typical way. If I want to compare the volume of box one and box two, that's how I'm going to do that. Well, I'm actually going to show you a different way to do it, and I'll let you compare this two. So I'm actually have two different version of the same code. The upper example is exactly the same one I showed you earlier about box one and box two, but the below is a overloading version of the same code. Essentially, these two codes, syntactically, semantics work exactly the same. But you can see that instead of using a member function called compare volume, I'm actually using an operator greater than. Okay, I'm using the operator greater than. So So let me before I kind of go into another question, I just want to tell you what is operator overloading. I will use this example. Is essentially object one dot operator, but I'm actually going to call that operator. Looks like this. I'm actually treating the operator itself as a member function. And then it has a parameter, which is object two, and this could be object two of another class. Okay, so this line I wrote it here is exactly this line, but I'm actually just used two different notation to represent that. So in other words, what I'm doing, if you look at the top example to this line I wrote, and then to this line, essentially it's just a different kind of representation about certain function. And the purpose is really for readability. I mean, to me, operator overloading is really for readability. It's nothing fancy. It's just make your code read better in certain situations. So okay, that kind of lead to my next question. So I gave you two examples. One is box one compare volume box two. One is box one greater than box two. Which one is you think is readable from the programmer perspective? You saw somebody else code. Which one you prefer? It's actually controversial in terms of your answer. I want to, which means that's something which you don't want to kind of definitely follow your textbook or follow your instruction. By the way, as a programmer, never follow any textbook, never follow your instructor about what they're saying. Write your own code, test it, then you determine what you like. Okay, you have an autonomous decision about what's right, what's wrong. So okay, I want to just have you share your opinion about, which way you like. It doesn't matter. Yes, please, in the back.
First one,
The first one, why?
you read less.
You think that one you read less? The first one, you mean this one, right? You like this one better? Okay, so you think that's why? You said read less? Okay, I think I can understand what you're saying. But hold on for your answer. What other, so nobody liked this one? Okay, why you like this one? I thought I'm going to say, hey, please burn the chapter 12 your textbook, okay? If nobody believes it. Yeah, go ahead, sorry.
I like the second one more because like all throughout math, it deals with those operators and it's just already in my mind. So it's just to look at that than the dot compare.
Right, okay. It's actually more readable in this case. But on the other hand, I want to, what's your name? Varden? Okay, I have to gradually learn. I'm very bad. It's my fault. Okay, you have a beautiful name. What's your name?
Ethan.
Ethan. So okay, that's easier, a little bit easier for me. So Ethan, talk about the readability of this two, box one and box two. It's kind of naturally fit with what we learned from arithmetics or mathematics about how to represent things in Greek letter and things like that. Well, but what Brandon? Okay, you have to teach me separately. Come to my office hour sometime. Figure out how to say your name. All right. Otherwise, you're in trouble. All right. But for the first one, he says read less. Okay, this is my interpretation about read less. Is that if I use this notation as a reader of the system, I actually have to read your code more carefully. I have to read your code about, exactly how you implement greater than. Because implement greater than, that means, I mean, what are we comparing between box one and box two? I mean, if you think about that, if this is the first time I read this code, I don't know whether they were talking about box one over box two in terms of their, say, their review score, or it's because they're volume, or it's because they're price. So there is kind of, sometimes depending on how you apply, that you don't sometimes really sure what the box one compares to box two. I mean, just like the person, when you compare two person, are we compare their age or compare their health index, such their heart rate or their blood pressure or the risk to get cancer? Okay, so those kind of things is really interesting. But typically operator overloading, sometimes I want to say, if you think about this as just for readability, sometimes you really have to make sure that when you say this operator is so clear, everybody actually knows about the meaning of this, and then you use operator overloading such that your code can be shared easily with others. But if the code is only used by yourself, you never intend to share your code. You want to do it yourself, then you do whatever you want, whatever you feel comfortable, that's okay. But if you want to think about other people using your code, that's what you need to worry about. Okay. All right, so now let's actually look at the implementation of this overloading. I thought I have the code somewhere. Yeah, I have the code. Okay, here. Okay, this is the implementation of that code. You can actually grab that code from your chapter 12, the first example. Essentially what you did is you declare something using the keyword operator and put a greater than, and then it return a Boolean this time because the operator is return a Boolean. And then you said constant box, a box, another box. Okay, that's how you declare. That's the same. If you declare this way, that's why, hold on. I show you that this kind of format is equivalent to this member function. So, okay, I'm using this. So instead of using this, I would just say the keyword operator. Okay, if you define this way, you kind of overload the meaning of greater than. And when you use it, you can actually use it this way. Okay, there's some tedious small things I do want to emphasize before I move on. So typically, when we declare operator overloading, we put two const in there, two const. That this, I put a const in the object I try to bring in, and also put a const here. So which means this two consts actually two different enforcement I want regarding the object. The inner const between that parentheses is basically say, hey, I let you use this object in some way, but you may not change. You must not change the value. The compiler is going to check. Okay, this is actually done by the compiler. Compiler is going to check the code to say whether your code in that operator overloading implementation does not try to change the content of the A box, which is object. And also the const operator greater than outside basically say, hey, you shouldn't change yourself either. So this function is declared has to be just comparison and without changing the content. It's just try to, the programmer try to avoid he himself or whoever used the code later try to modify to change the semantics such that it alter the data. Okay, so just let you know. Okay, yes.
A function, if you then use the greater than operators compared to integers, does it still work?
Yes, it still work. Okay, so that's a good question. So let's use a different example. Let's go back to the distance. Is this a distance? Okay, good. Okay, in the function that's in the class that we have seen, 1 second. You see that I actually declare an operator over here, which is it returns double and it has an operator, and then this time I overload the operator minus. All right, I overload that operator minus, and then again, the parameter it takes is GPSDD. Okay, that's the operator we're going to look at next. So just let you know, I override the meaning of the minus operator as the distance, which I will show you a bit later. But here, go back to the question, what's your name? Crystal, okay. So what Crystal was asking is that, well, if I overload the operator minus, will that change anything in other part of the program using the operator minus? So in most cases, it will not. In some cases, it will. But let's actually look at the concept again. It's called function signature. If I mention the term function signature, what does that mean to you? Function signature. So let me say, what is a function signature? Function signature, which is very important concept, by the way, in any programming language. So function signature is when you write a program about a function, what feature about the function such that uniquely identify what this function really is. So for example, you could have multiple functions share the same name. So related to Crystal's question, minus, you can think about minus as an operator, but today you change your mind that minus is actually a function. It's a function that could be overloaded. So therefore, the function signature has to be determined in a way such that I will be differentiate that whether this minus operator has been overloaded to another meaning or is actually remained the same. Okay, so let's first talk about what's the definition of function signature. So function signature have a 3 element. The first element is a function name. The name is always one of the part of the signature. The second one is a return type. Okay, in C or C++, you can only return one thing. So that whatever that data type of that things you want to return. Okay, that's the return type. And then the third thing is argument and their type. I mean, it's really just argument types. Types of arguments, including the number of arguments, okay? Okay, so if I compare 2 functions, they are the same function. That means all 3 things has to be identical. Means that they have the same name, the same return type, and the same number of argument and their type. Okay, so these 3 things, if they match, that means these 2 functions are identical function. Okay, so to talk about this, then we have to look at this. Now let's go back to here. What is the name of the function? It's actually operator minus. It's a minus. Essentially, that's the name of the function. And then what's the return type? The return type is double. It's return the double. The previous example I showed you with the box is returning a Boolean value. But operator overloading, you don't have to return a Boolean. You can return anything. You can return even an object. But over here, I'm actually return a double. And then I do what I call the type, the number of argument, only one argument. And then the type of the argument is GPSDD. Okay, that's the function signature. So in other words, go back to Crystal's question. If you overload the operator and it match with all the 3 conditions, then it's essentially will be affected. But otherwise, it won't be affected. In fact, I will show you another example. Take a look at here. I have another operator overloading. which is double operator minus the same, but the input argument type is different. It's an integer. The input type is an integer. What does that mean? It means that this two, the function signature is different. So there are two different functions. It's just like I have a two different constructor. Okay, so which means that depending on how you're going to use it, is going to be different. Any question? So let me show you an example how I use this. How I use this operator overloading. Sorry. No, not this one. That's okay. I will show you first operator overloading implementation from the CPP perspective. Okay, so now take a look at the function operator overloading. If you look at the code, this code is essentially identical to the distant code I showed you earlier. If you compare, let me make it a little bit bigger so you can see both functions at the same time. This is really just for readability. How do I make sure they're fit in the exactly the same window? Okay, I gave up. I do this. Okay, if you compare this two function, the top is operator overloading of the operator minus, and the bottom is the original one, the distance that we talked about. And inside the distance, I call this geo data source. Remember last time we talked about this? With this 5 argument put into that and then get a double, which is represent the distance in miles. You look at the top part, it's the same. It's exactly the same. I'm just extracting all the element from both this and another, and I return the same thing. Okay, so that's the implementation. The implementation is just doing whatever I want them to do. Okay, so now let's look at how I actually use this example. Use this operator overloading. Okay, this is the line we did last time. Remember, I called a function from object 1, which is a GPS home.woodland.distance, and I put GPS TLC UC Davis as the argument, and I calculate the distance returned from the function is distance 1, and I print the distance like this. But equally, this is operator overloading. I'm using minus. Okay, I'm just basically do a minus between these two GPS objects. And then the return value, remember, the way this line works is essentially the same as this. I just want to tell you that what this line is internally is distance underscore 1 is equal to GPS. Let me just copy it. GPS dot the operator minus, and then like this. Okay, these two are essentially the same. So the minus is the same as the distance because you saw that the implementation is the same. And then it got the same result. Okay, now I'm going to ask you the other question. Which way you prefer? Do you prefer using the minus or you prefer to use the distance? It's kind of controversial. I mean, by the way, using distance to me is unambiguous, and I understand. If I use it, I understand. But using minus, sometimes it's a bit artificial, and which I have to think twice. What do you mean by minus? Are you minus latitude or minus longitude or minus whatever the calculation of the distance using the function, right? I mean, it's a controversial. Does it look nicer? Maybe a little bit. I mean, So anyway, I mean, if you decide, by the way, usually the typical way to do this is as a programming team. The team has to decide what kind of operator they would like. They have to review together what kind of operator they like to overload, what kind of things they don't want to overload. Okay, as a development. But now I want to tell you as a reader, which I actually surprisingly encounter numerous times, that I have to read other people's code. And especially from GitHub, from open source. I want to kind of do some development and try to modify. And there are numerous times I actually realized when I look at the code, I didn't realize until later I realized, oh, it's operator overloading. And then I have to go to actually check where is the source code about that operator overloading. Sometimes I found it, sometimes I don't, I cannot even have it. So I have to kind of test it to see what that really means. Okay. Okay, any question about this example? Yes, please.
If you do this, can you make it like 2 charts or 3, like more than one character?
You could have a 2 character if this 2 character is a operator already in the language. For example, you can have a greater than, that's fine. But if you, I actually thought about something like this. Let me try to do something. What's your name? Python. Okay, I like Python's question about, you know, what kind of operator you can put it here. So let's try a few things. Let's try make it modify this. I mean, I know this will work, greater than, because it is already an operator in C and C++. And I'm not sure about this. Let me check. There's a list of operator that I cannot overload. Let me actually check. I should have it writing down somewhere. Okay, there are a few operator I cannot overload. Those operator I cannot overload. Okay, it's just defined by the language because the meaning of those and then other than that, everything else here can be overloaded with a multiple character. But I have been thinking whether this is considered overloading. I never try it. I want to try it now. So this is you can think about this as dash greater than. This is pointer, right? It's a pointer. Can I actually overload a pointer, or can I actually overload something else? Say 3 equal sign. Oh, I probably cannot. Okay, or 3 question mark. Let's see what the compiler will complain. Yeah, I cannot overload. I cannot overload the pointer. I cannot overload whatever more than 2 character and things like that. Okay. All right. So that's the answer to type. Yeah, the language is not creative enough. I mean, otherwise I will overload a lot of different things, which is I feel the next generation of C++ should allow more of this flexibility about other kind of operator I can overload. Okay, good. Let me go back to the code so I can modify. Peel the back. Okay, so now I'm actually going to introduce the next class, which is a class person. And then we'll see how we can overload some of the operator over there as well. So first take a look at person.h. So person.h is a file which we try to represent a person. You can see that some of the information I included here, and this will be useful for your homework assignment number 2. All right, so I'm going to release homework assignment number 2 very fast. Neglect about this inheritance. Okay, person is inherited from immutable. You can neglect that, but later you will learn that after we finish chapter 12, we'll go into inheritance immediately. So it has a bunch of strings, such as VSID is just the way I implement a virtual social security number. I don't want to have any real social security, so I use a virtual social security. And you have whatever the name or avatar, and then you have address. Okay, the address, which is a home, and then you can basically. Oh, by the way, here I'm using a pointer notation instead of using the value as a pointer. Okay, so that's the person basic attribute, and then I have a bunch of stuff I want to show you. The first one is, of course, I have a 3 different constructor. I have a 1 destructor, and then I have a bunch of member function such as set home, get VSID, get name, get home, those kind of things. And then I have operator overloading. Okay, this 2 function is called dump to JSON and JSON to object, which I will spend a lot of time talking about why I have those 2, and they're both virtual function. Virtual function is probably one of the most difficult concept in the whole C++ programming language. If you ask me what's the most difficult concept in programming language is C, it must be pointer, the notion of pointer. And in C++, the most challenging concept is a virtual function. All right, so just give you a heads up. All right, so now that's the example of operator overloading. Is an equal operator, and with a person, the person object with the other person. So that's operator overloading. So let's actually take a look at the implementation of operator overloading. So if you look at the operator overloading over here, I'm just basically comparing a person just purely based on the VSID, the social security number. So I'm assuming that the student ID or the social security ID must be unique. So the equal is essentially is just compare those 2. Okay, whether it's readable or not, it's hard. Okay, so which means that when you want to understand what really the meaning of this equal sign, you pretty much have to look at the source code to understand exactly what's compared. I mean, an alternative implementation could be this. An alternative implementation could be, sorry, I will have to add this. Okay, so I could just basically say, hey, I require 2 person are equal. Not only they have to have the same ID, but also their name has to be the same. That's 2 different implementation with 2 different meaning of the code. Therefore, if you want to decide which way it is, you have to look at the code here to decide, whether it works. So by the way, what is this name? This name is a string. And a person get name is also a string. In C++, in C, how do you compare 2 strings if they're identical? What function you should use? string compare, right? String CMP or string NCMP. Those two are the function. But this is, by the way, in C++, we're introduced another command called, another pointer string called capital S, lowercase tring, string class, which is similar to the C++, C style string, which is character star. But it has all the operator such as equal has been overloaded such that it has a similar semantics to string comparison. Okay, that itself is a potential way you can think about is operator overloading. You can take a look at the string source code to see how it works. Okay, all right. Any question with operator overloading? Yes.
So the ampersand being passed in for a person, if it's passing the address of it, and if so, why don't we have to use the arrow for whenever you're accessing something in the person?
Okay, good question. I forgot to explain this. So this ampersand is a reference. It's a reference. So in C, there are 3 styles. By the way, I can write it in 3 styles. By the way, I forgot when I should talk about this. I can probably skip to talk about this a little bit. I have a 3-way to pass parameter. One is person, one is person star. Okay, compare the 3 things. I use person and sign there, and then person, a person, and person star, a person. Okay, so let me as a C programmer, okay, as a C, because the first line I used, that was a C++ notation. But the 2 lines below, which I commented out, those are C style. Those are the C representation of something. So let me actually ask you, what's the difference between these 2? Yes. That's great. One is passed by value, one is passed by pointer, right? Okay, so there was 2 terms. We call them call by reference and call by value. So that's sometimes we use your term pass by. So call by value means that you call a function that you send the stuff into a function, and the thing is that regardless how inside the function they want to change the value, it will not be seen by outside of the function. That's called by value, right? Pass by value. And call by reference is exactly the opposite. You try to pass something, whatever it modify, it actually modify the original copy. Okay, so just want to tell you that person M, in terms of their semantic, compare call by value or call by pointer or pass by value, pass by pointer, is exactly the same as a pointer. So from that perspective about whether inside can modify is actually passed by pointer. But in terms of its a usage is exactly the same as this one. So meaning that I'm not using this notation, I'm using the dot notation. Okay, so this is exactly the same. And you can think about it this, except they share the same memory. This is confusing, right? I mean, if you never solve all this program, that's why sometimes I kind of hesitate to use the M, because the M is really represent a call by reference, but syntactically it looks like is a traditional call by value. Okay, that's the first way I'm going to tell you. The second thing I want to tell you is the difference between these 2. What's the main difference between these 2 in terms of memory usage? So this is important for Java programmer, Python programmer, you don't need to worry about this. But C programmer, you have to worry about memory usage. Okay, C is essentially the only language that you directly access your memory in address. Okay, so the difference between these 2, this one and this one, or this one and this one, is that if I call the function with a person, without the M, I'm going to make a copy of the whole object. Because it's called by value, I have to copy the entire object to create another copy in my memory. And then I pass to the function to let the function do whatever they want. But if I add the M sign over here, that means I'm actually really just pass the reference. I'm not passing the value. In other words, I'm saving some memory copy effort in my system. Okay, so so you can think about semantically, person N is the same as person star, semantically. But syntactically, when you want to use this object, it's the same as the person and person. Okay, now you start to get a feeling about why I hate using the C++ call by reference. It's confusing. As a C programmer, I feel this too already cover everything I need. Now they introduce something else, which is in some sense they work with this. Looks like I'm actually doing this, but in some sense, okay. This is my personal bias interpretation about the evil intent of the design of the language. By the way, this was not introduced initially as a C++. My feeling is that there's so many people hate C pointer. Really, there is a lot of people don't like C because of pointer. I hope you can relate to my feeling. Okay, so what they did is that they tried to redesign the language such that it looks like you don't have to use pointer. You use something called reference. Okay, I mean, yeah, you can just use between this, and then you can do a lot of stuff, like a call by reference, and then you can avoid introduce this star notation. That's really, I mean, my interpretation about why you need to introduce them. Okay. All right. So I'm going to stop my complaining about this language as an instructor, right, at this moment. Any question? Yes. Um, if I understand your question correctly, what's your name? Erica? I think it is not possible. So it really go back to function signature. So if the name operator is the same, if the return type is the same, if the input argument is the same, then essentially you must decide, because it's the same function. So you must decide this function will compare age or compare, say, their blood pressure. If under that function signature, there's only one thing you can compare. I mean, unless, okay, the other thing you can compare, of course, is you kind of within the same function, you compare multiple things, and then you kind of put the result into another data structure and you return that. That's fine, but that's not going to be a Boolean. But the Boolean must be true and false. Okay. Right. So I wrote the code, however, I try to twist their function signature. Oh, I know what I did before. Okay. I did this. This is the only positive thing I would like to say about the reference. Okay, so if I have a function, which is the input argument is a person versus person n, this two consider different function signature. So let me actually show you what you can do. Let's go back to the GPS example. So I have operator overloading, looks like this, right? Double operator minus GPS DD. I can actually do this. Okay, I can actually do this. These two are considered different function signature because one is called by value, one is called by reference. And therefore, I will be able to do this, to specify. However, when I call it, this will create trouble. When I call it, the compiler needs me to decide which one I'm using. So therefore, I have to cast specifically on the object itself, on the GPS object, about whether it's N or M. Let me actually try this. I have a 2, and so I'm going to. I haven't done this for a while, but let me see. I believe it should work. Okay, so I have an operator over here. And then I have the other one, which I call it N. Okay, I have a different one, but over here, I'm just saying return 0.0, okay? Just make it simple. Okay, if I do this, let's see if I can compile. Oh, I have an arrow. Oh, you see, it says it's ambiguous. So this one is ambiguous because I can match to both of them. Okay, so it's not complaining I cannot have that. It's complaining the way I use it. So I have to be explicit. So let's now go back to the code, the program where I really want to use that function. So over here, the complaint is this part. So let's do this. If I say GPS, ED, if I do this, this is called casting. I kind of, when I have an ambiguous situation, I kind of add the things over there. And then I can just do the same thing. And the second one, I will do GPS N. Okay, so I kind of cast with whatever, using the casting such that the compiler know how to match the overloaded operator. Oh, I have the other one. That's about the GPS. Is that right? That's only about the other part of the code. What happened here? That's actually very strange. Overloading. Why I have a multiple place? That's strange. Minus. I already overload this. Okay, I would just casting both of them, see if that will take care of the issue. Which is kind of surprise. Okay, let's hope this. Oh, I have another one over here. So I will let's just get rid of this first. Let me just get rid of all the operator overloading, which is, and just focus on those two lines. I still have one has a problem. That's very strange to me. With Okay, I'm going to do this and just quickly do some other study. So I'm going to get rid of this one first. Okay, so apparently, let me tell you that what I found out. So I can actually define two operator overloading, but in order for me to use it, I have to cast this specifically to the function signature that's actually consistent with the, let me just do it this way. This way should work. Oh, still, I have to cast both of them. That's actually, oh, no, it's different. GPSDD, no. Well, that's a different reason. Did I do something wrong? Oh, I missed this parenthesis here. Okay, so this work by doing specifying between the reference and the call by value, I can have a two operator overloading, but I must explicitly set GPSDB over here in order to do that. But for this line, I still need to figure out why I actually have this issue, why I cannot just cast GPSDB. I will go home and check it out. I believe there's a way to do it. I think I have done it before, such that I really want to have two operator overloading for different meaning, but I want the function signature looks the same. I remember I have to play some tricks in terms of casting to make sure that the compiler knows which one I need to use. Okay, I'm not recommend us to do that in general. It's just you can do that, but sometimes make the code looks ugly and confusing. Okay, that's what I want to say about operator overloading. Okay. All right, good. So I need to teach you all the syntax about operator overloading, not because you need to use it. Okay, it's mostly because somebody else use it. You have to understand how they do that. Okay. All right, I'm going to finish the other part of operator overloading, which I call this standard or whatever we call the OPS, operator overloading. Let me actually move to this part. Okay, there is a template. I mean, toward the end of the quarter, I will talk about what do I mean by a C++ template. You can have a template function, you have a template class. So template is a very powerful concept in object-oriented programming. And at this moment, I just want to introduce you some kind of templates that related to operator overloading, which is kind of handy for you to do. So there are 6 what we call the comparison operator, which is, I put it here. Those are the 6 operator, which they all have to do with a logical comparison. They all return Boolean value. Okay, so you can see they're equal, not equal, smaller than, greater than, smaller than and equal, and greater than and equal as well. All right, so one way you can think about this is that, well, if you want to use a comparison between 2 different objects, you're thinking, okay, I need to overload all 6 of them, right? You need to overload all 6 of them so you can use all 6 operator. But the thing is that you don't have to. It turned out you only need to overload 2 of them, and the template will automatically pick up the other 4. So the thing is that in the C++, in my environment is under that pass. There is a file called utility. Inside utility has a template being defined. And the thing is that you only need to define equal and the smaller than. You only need to overload 2 of them, but through the template, all 6 are covered. I mean, the way they implement is very simple because you already have the equal and the smaller than, then you can easily implement the other 4. For example, if you have an equal and smaller than, you can actually automatically implement smaller than and equal. And then you have a not, because not is always there, just reverse the result. So if you have an equal, automatically you have a negative not, negative equal. So this is a library, we call it template library. You can see that the code is for example, remember I said we already overload equal and the smaller than, and then the operator smaller than equal, what they did is they just basically using the, okay, how can this be? Okay, they reverse the parameter, they use smaller than, and then they actually use not to actually do the implementation as a template. Okay, so this is sometimes if you want to use this kind of relational operator, you can actually use this template, related operator overloading. Okay, so I just want to very quickly summarize what we did for chapter 12. Essentially, we talk about operator overloading. My comment is just be careful and use it appropriately. There are some tricks that you potentially learn. For example, how to match the function signature and things like that. Okay, any question before I start moving to chapter 13? Yes.
Back on the slide where you were showing the implementation of the box, why don't you have to do this if it's a function within the box?
This one? Or this one? This one?
Why don't you have to return this arrow volume?
Oh, why I didn't do return this volume? Okay. If I roll the code, I will. This is actually from your textbook. Yeah, that's a good point. Yeah, so adding this is I think is enhance some readability. Yeah, they're the same. Okay, any other question? Okay, so now I want to go into chapter 13 to talk about inheritance. Let me see. I just want to make sure I have finished all this. Oh, I cannot. I have to do something else. I have to talk about, there's another thing I need to talk about is constructor and destructor. Okay, I thought I forgot something in chapter 12, is constructor and destructor. So we just finished this utility. I thought you heard me saying the utility and how to use the template. So now I want to talk about how do I do this kind of a different type of constructor. Okay, so let's first worry about constructor, then we worry about assignment. There are 3 types of constructor. So we already seen some of the constructor that you can like here that you can call the function and whatever you want to do. In the example of GPS, but really we have 3 different types of constructor. One is called default constructor, one is called copy constructor, and the other one is called move constructor. So the color match with the color value over here, which is the purple is default constructor. The default constructor, we already use it, is essentially calling it without any argument. And then within that constructor function, you decide how you're going to set the initial value of your member attribute within the object. And the second one is called copy constructor. So copy constructor, essentially you are passed in as a reference. You put in one M sign, you actually put it in. And what copy constructor is doing is I pass in some kind of value, and you basically copy the value to the new object. And then you essentially just started with essentially a clone about the object that you pass in this case. So the green is called copy constructor. The one that's actually kind of surprising, and it hasn't been used, in my opinion, not very much in terms of programming, is called move constructor. Move constructor, you actually pass in with 2n. You pass in with 2n, okay? And then what you did is that the move constructor is you don't make a copy, but you make the original memory that's related to the object you pass in as the new object. So essentially you move this object into the other object. The original object will be gone, and you just have that object over there. So that's called move constructor. Okay, so let's show you some example. Okay, I'm going to show you some code for this. So you can see that I have a default constructor, copy constructor, and I have the move constructor. And the way to call it is that for the default constructor, you're essentially not doing anything, just basically get a new copy and whatever value you set it. And for the copy constructor, what you did is that you can see that you assign the value from the A data, which is the data you're going to put in over here, and you assign the value over here, and that's it. Okay, so this is essentially the copy constructor that you copy the value. And the third one, which is this part, is the most confusing, is called move constructor. You can see that I actually didn't create that particular object. I directly use the value pointer and put into this pointer. So I move the memory address into that, and that's it. Okay. So that's the three style of the, so by the way, one thing I forgot to mention is if you haven't seen this before, that in C++, instead of using malloc, we use this new command called new. New is the same as malloc. So when I say new data, that this is equivalent to malloc, whatever the size of data. And then the pointer will go back to data star. And when you want to delete it, just like a free, you do a delete. Okay, so that's the constructor. Okay, any question about the three different kind of constructor? Move, copy, and default. So, okay, now is my biased opinion. You almost, it's rarely for you to need to use move constructor. Just period, because that's my experience, is that you always have another way to handle the move situation that you don't need to use the move constructor. And I see a lot of open source code in C++. I hardly ever see anybody use. Have you, any of you have done C++ programming before? Okay, have you seen move constructor? Very rare, right? Okay, why are you in this class? No, I'm just kidding. It's probably because of a curriculum require you to be here, right? Okay, I understand. All right. I respect that. Thank you. All right. So, so what I'm saying is that you have this. Is already, some of you already see this, whatever class with a 1M sign, which is already kind of confusing you. But this is data MN. That's just like a pointer star, star. I mean, in pointer, I use integer star, 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 star. Sometimes I put 3 star. I probably use 4 star once in my lifetime in the past 35 years, but it's just using star. I mean, this is getting more and more confused. I don't just tell you this thing exists. If one day you saw more than one M sign after the class, you basically take out the textbook to read chapter 12. Okay, that's the only thing I want you to know. Okay, so that's a perfect timing for me to finish chapter 12. I'm going to start with chapter 13, which is inheritance, which is the big thing, the biggest thing in the whole ecs36b. Okay, see you on Tuesday. Oh, by the way, just let you know, I changed my office hour because Friday it turned out I have a conflict. So I moved my office hour from now I'm going back to my office until 12 p.m. on Thursday.